questions. So start with your table N and find the name radium-226. And then when you look at the column next to it, you can find the decay mode. And radium-226, it gives you this funny looking symbol. And if you go and look at your table O, it will tell you that this is an alpha decay. So radium, if you're not sure of the symbol, the same table, table N, where you see radium-226 in the right-hand column, move all the way to the left and it will show you the symbol of Ra and a mass of 226. We know that when it goes through its natural transmutation, it gives off that alpha particle. So we can look on table O so we understand the symbol to write down. So we put He with a mass of 4 and an atomic number of 2. Our job is to figure out the new element that forms when the radium-226 emits this alpha particle. So in order to do this successfully, we also need to know radium's atomic number. So we can look on the periodic table and it says it has 88 protons. So radium-226 ejects this alpha particle. The alpha particle takes 4 of the AMUs from the 226. So the new structure has a mass of 222. So 222 plus 4 gives us 226. The alpha particle also takes 2 of radium's 88 protons. So the alpha takes 2, the new structure has what's left over, which would be 84. So 86, I can't count. 86 plus 2 equals 88. So we need to find an element on the periodic table that has 86 protons. And when you look on the periodic table, we will see that the new atom formed is radon Rn. Our next example is Tc99. So when you take a look on the periodic table, or on table N, Tc99 goes through a decay mode. It's that funny looking B with a minus sign. And when you look on table O, it will tell you that it goes through a beta decay. So we start off with Tc99, our unstable nucleus. It goes through its natural transmutation, and on table O, beta uses an E with a mass of 0, and it affects the atomic number with a -1. Our job is when the Tc99 ejects this beta particle, what is the new atom that is formed? So we also need to know Tc's atomic number. So when you look on the periodic table, Tc is element 43, 43 protons. So the beta particle takes none of Tc99's mass. So the new atom has a mass of 99. The beta particle affects the atomic number by -1. So whatever we put here for the atomic number, this number plus the -1 needs to add to 43. So if I put a 44 here, 44 plus -1 equals 43. So my new atom has an atomic number of 44. And when I go look on the periodic table, atom 44 on the periodic table uses a symbol of Ru. Last example, I'm changing it to a mass of 235, so U235. And when you go and look on the periodic table, U235 has a decay mode of that funny looking fish symbol, which table O reminds us it is called an alpha decay. So U235, when it goes through its natural transmutation, it emits and gives off an alpha particle, and table O shows us we use He42, and our job is to figure out the new atom that's formed. We need to know U's atomic number so we can find that in the PT, which is 92. So every uranium uses or has 92 protons. When uranium-235 decays, the alpha particle it ejects takes 4 AMUs with it. So the new particle's mass is 4 less than the uranium. So the new mass would be 231. 231 plus 4 is 235. The alpha particle also takes 2 protons with it. So the uranium has 92 protons, the alpha takes 2 with it. So the new atom only has 90 protons in its structure. So we look on the periodic table, and the element that has 90 protons in its nucleus uses the symbol TH. You now go ahead and try the you-dos listed below and check your answers with the teacher. Full decay reaction and identification of the decay mode.